Okay, things are going to get a little bit more interesting now. So we've got a couple more examples, and what we'll see this time is that sometimes the power on our factor will not be 1, and that does have an effect on the shape of the graph right near the x-intercept that you get from that factor. So let's start with our factoring as usual. This one with the 4 terms, our best bet generally if we have 4 terms is first look for a common factor and then try grouping. So I do see a common factor here. I see a common factor of 2, and I'm thinking since that x cubed has the negative, I think I might just take the negative as well. That's a choice. You don't have to factor out the negative sign, but it feels like it's going to maybe keep me from getting in trouble a little later on. So I'll be left with an x cubed, and then this will be a plus 2x squared, and then a minus 4x, and a minus 8. Okay, so if I go ahead and group this, group number 1, I can factor an x squared out of, and I'm left with an x plus 2. Group number 2, I can factor a negative 4 out of. Be very careful. As soon as you put that negative in front of the parentheses, you are factoring it out. So you're dividing by negative 4, which leaves a positive 2 in there. Okay, so negative 2 is still out in front. We can now, I'm going to go ahead and make these brackets just so you can see where things ended up. So we have that bracket. Inside the parentheses, we ended up with a common factor of x plus 2. So I am going to remove that. The operation, the big operation is that subtraction. So that's where I'm splitting it into 2 terms, and each term has that x plus 2. What's left over is an x squared minus 4, and that I can do better with. So I am going to drop the brackets at this point. This is all just multiplication, and the parentheses are grouping everything fairly well without needing that extra set of brackets. And while I'm at it, I'm going to split the x squared minus 4 into an x plus 2 times x minus 2. And notice, this is what's interesting about this one, we do have a double factor. So that's still telling us there's an x-intercept at negative 2, but this is sort of a special x-intercept. It's like 2 of the zeros of our polynomials got kind of mushed together. So I'm going to rewrite it just to really emphasize that. It does matter if you have a repeated factor. That's a repeated x-intercept. And what we would say is that that factor has multiplicity 2, or we can even say that the x-intercept at negative 2 will have multiplicity 2. So we do have zeros at negative 2, 0, and at positive 2, 0. And we do want to note that this one has multiplicity 2, because that will matter when we're graphing. Before we jump right in and just look at the graph, I'd like you to see some values of the function. So I've made a spreadsheet so that we can see if we can get a little insight into why the graph does what it does. So what I've done is I've put in some x values near the intercept negative 2, and then the blue is some x values near the intercept at positive 2, and I want to see what's happening to each factor. So note that that negative 2 out in front is a factor, but I've just left it here. It doesn't change. It's always negative 2, so not very exciting. The x plus 2 squared, that is the x-intercept that gave us x equals negative 2 as a 0. And notice that what's happening with it is it's getting really, really close to 0. And usually what we would see is if it started off positive, it would become 0, and then it would switch to negative. But because of that square, you're not getting the switch. So we're not actually going to cross through the x-axis. Notice the x minus 2 is not doing anything terribly interesting. It's just over here being close to negative 4. So that's not really determining a lot about what's happening at this x-intercept. Of course, it does have some effect on it, but it's not going to change signs, so nothing too crazy is happening. And then this last column is the actual y values when I multiply all of that together. So you can see I have a positive y value, a smaller positive y value, and there's my x-intercept at 0, and then instead of crossing through, I switch back to positive. We can contrast this a little with what happens at x equals 2. So note that x equals 2 comes from the x minus 2 factor. So I plugged in numbers a little smaller and a little bigger than 2. And again, you can see that negative 2 out in front just is what it is. The x plus 2 squared, it's just off doing its own thing, giving us numbers close to 16. So nothing too crazy happening there. All the interesting stuff is happening with the x minus 2, where we're getting these tiny, tiny values that's making the whole thing drop down closer to 0. And because this doesn't have the second power, we see what's more normally expected. We see that we're getting some negative numbers when we plug in something just a little smaller than 2, and we're getting 0 when we plug in exactly 2. And then if we plug in something a little bigger than 2, we get positive numbers. And we can see what that does to our y values. Notice that our y values actually start off positive, and that's because 2 of our factors are negative. So that ends up giving us a positive number. And you can see it getting a little smaller and then hitting 0, and then it does cross right through and switch to negative numbers. So if your factor has an odd power, you will cross through the axis. If it has an even power, you will actually bounce off the axis. So let's go ahead back here and graph. Otherwise, our strategy is pretty much the same. Degree, I keep skipping that at the beginning because I'm so excited to jump into my factoring. The degree is 3, and the global behavior will be y equals negative x cubed or negative 2x cubed. I don't care if you include the 2 or not, but I do want to see that it's upside down x cubed. So that should look like that. That's an upside down x cubed. And what that tells me is that as x gets really, really big, which means we're imagining heading out the right side of this graph, our y values are getting really, really negative. And as x gets really, really big negative, we're now imagining we're headed out the left side of our graph, and y's are getting really big positive. Okay, so all that global behavior stuff just tells us what to do at the far left and the far right side of our graph. So let's put down what we have. I am seeing zeros at negative 2 and 2. I'm supposed to start up here at positive infinity, and I have to come down to this x-intercept. But at negative 2, we had the multiplicity 2. So this one is going to have to bounce off the axis. And it doesn't always have to bounce and stay above. You could start below the axis and bounce and stay below. It doesn't tell you positive or negative. It just says it doesn't change signs. It'll bounce right off the x-axis. And then we're going to go up for a little while, and our next piece of local behavior is another x-intercept. It's multiplicity 1, so we will change signs. We'll cross right through and head to negative infinity. And that's a complete graph for this function.